In order to handle adding and subtracting, we need to have our fractions on common ground. Kind of like wrestling, like the Olympic style wrestling. You've got weight classes. So you want to bump up to a weight class, you've got to gain weight, you want to drop down a weight class, you have to lose weight. And it's kind of like that with fractions. If you want to put two fractions together, they've got to be in the same weight class, which means that what they have to have is the same denominator. What we'd like to have is the smallest possible denominator that would work for the fractions that are in our problem. So the smallest one that would be common, which is the general everyday way of saying the least common multiple of whatever numbers show up in our denominator. In order to figure out this least common denominator, we could try to use a little bit of what we've talked about before with our prime factorization. Knowing how most people feel about prime factorization, though, the bigger numbers that we get, the more irritating and the longer it might take to come up with an answer. So while you could follow this three-step process here that I've laid out and used in this first example, generally people feel that that's kind of icky. So we're going to try something that uses some of the same ideas, but is a little bit more basic in terms of the work that we're going to do. Rather than working through prime factorizations and having to remember very particular ways of picking the numbers that we need in order to create our least common multiple, we're going to take a different approach. We are going to instead use this alternate way of working through things. We're going to start with the largest number that we have. And again, for right now, it's just a list of numbers that we're working with. 24, 36, 120. We're going to start with the largest number. Well, that's a very basic thing for us to pick out. The biggest number that appears in this list is 120. Now, if we're lucky, this is the number that we would need, that smallest common number that we would eventually be able to use if we had these as denominators. Well, it either works or it doesn't based on division questions. Is the 120 divisible by the other numbers that we have shown up? Is 120 divisible by 24? Well, it turns out that it is. So that's nice. Is 120 divisible by 36? Turns out that that is not. So, if 120 didn't work, we'd like to come up with another possible number that might be the one that we're looking for. But again, we don't want to get weird, technical, or do anything that's time-consuming or difficult to remember. We'd like to keep things as basic as possible. So, let's try to take that largest number and double it. 2 times our largest number. Well, that means that we are talking about 2 times 120. 2 times 120 is 240. Now, that definitely works with the 24. So we would still need to worry about the 36. Specifically, we are worried about the division. The can we divide and get a nice answer? 240 divisible by 36? No. So we move on to step 3, where again, we're going to just try to keep things basic, and we're going to repeat the idea of bumping up the number that we look at. So instead of 2 times the 120, we will try 3 times the 120. That gives us 360. Well, we need to worry about is 360 divisible by both of the other numbers. And in this particular case, yes, it is. We have in fact found exactly what number we were looking to find. We would like to have the smallest number that will work with the 24, the 36, and the 120. I want the smallest possible number. 24 that we'll go into, 36 will go into, and 120 will go into. Well, I used the 120 to build this, so I know that the 120 works. And I just checked out the 24 and the 36 and say, hey, yeah, those will go into 360. 24 will go into 360, 36 will go into 360. Awesome. This is the number that I want. Well, this is going to be the first step of doing the adding and subtracting problems when we don't already have fractions with the same denominator. So overall, the steps that we've got going on for adding and subtracting with fractions, well, that first step, looking at the denominator numbers, we want this least common multiple. Well, because they're denominators, we can now refer to it as the least common denominator. I want the smallest denominator that all of my denominators will have in common, that they will all go into. So despite the fact that this says least, this is not a small number, it's actually a big number. How big? Well, it depends on what denominators we've got showing up. If we had denominators of 24, 36, and 120, our least common denominator would have been 360. Now that's just the first step. That is, what is the common ground, the common weight class that our fractions need to have? Well, then we're going to need to take our fractions and they're going to get bumped up. Best case scenario, one or more of them stays the same. We're going to need to make adjustments to those. Now, you can't just do all legs. You can't just do all upper body. You've got to make adjustments to your weight all throughout, top and bottom, so that you can be in that weight class. So whatever you do on the bottom to create your common denominator, you're going to do exactly the same thing to the top. Once you make those adjustments, then you can actually go ahead and do the adding or subtracting problem by putting your numerators together, keeping your common denominator, and now we can say always at the end of our fraction problems, we want to make sure to reduce if possible. So whether we're multiplying, dividing, adding, subtracting, we want to make sure that the answer that we give is fully reduced, fully simplified, in lowest terms, again, whatever phrasing you prefer. So let's consider an example here where we work through these steps. At the top of the screen, step 1, we need to find the least common denominator. So our steps were to look at those denominators, 6, 10, and 18. Start with the biggest one, 18. We want to know if that will be the number that we're looking for. Fingers crossed. Is 18 divisible by 6? Yes. Is 18 divisible by 10? No. That means 18 is not the number we're looking for. Let's take the 18, let's bump it up. 2 times 18 is 36. 36 still doesn't work with that 10, so I bump it up again. 3 times 18 is 54. 10 still giving me trouble. 4 times 18, 72. Still not working out. 5 times 18 give me 90. Now we've got something that is built with the 18, so it works with that number. 90 is divisible by 6, so it works with that number. And finally, 90 is divisible by 10, so it works with that number. 90 is going to be our common denominator. So I want to take each of these 3 fractions and I want to change them so that they will have a 90 on the bottom. I have a 6, I need a 90. 6 goes into 90 15 times. So on the bottom, I need a times by 15. According to my step up there in red, whatever adjustment I make to the bottom, times by 15, I'm going to have to do that up on top as well. So up on top, times by 15. Gets me a new fraction with a 90 on the bottom. Second fraction has a 10, need a 90. 10 goes into 90 9 times, so I need a times by 9 on the bottom, and what I do on the bottom, I've got to do up on the top, so a times by 9 on the top, give me a 9 over 90. And the third fraction has an 18, I want a 90. Let's not forget that we just went through 18, 36, 54, 72, 90. We just built that 90 by going through. Fifth number in our list. 18 times 5 gives us 90. So I got a times by 5 on the bottom, got a times by 5 up on top. All 3 of my fractions now have that common denominator. I can put my numerators together. Keep your denominator the same. Now I need to see how things work out. Step 4, reduce if possible. I built the 90. I know what works. I know a lot of versions of what works. I know 5 goes into 90. I know 18 goes into 90. I know 6 goes into 90. I know 10 goes into 90. Let's see what might work with a 29. 6 has a 2 and a 3. 2 doesn't work, 3 doesn't work. That means 6 doesn't work. That means 9 doesn't work. That means 18 doesn't work. Because 2 doesn't work, 10 doesn't work. Does a 5 work? Nope, 5 doesn't work either. Well, I pretty much exhausted all my possibilities. The 6, nope. 15, no. 10, no. 9, no. 18, no. 5, no. None of those work with that top number of 29. So I've considered the possibility of reducing and found that there is nothing that works, which means my final answer here is the 29 over 90. There is no reducing that's possible for that particular fraction. I don't want to forget to reduce if possible. Not all of my answers can be reduced, but if you have a fraction that can be reduced and you don't reduce it, you're going to get marked wrong. Partly or completely. So let's take a look at a couple of examples. First one being 1 over 18 plus 7 over 12 plus 1 over 4. The first step is that we've got to work out our common denominator. Our common denominator starts by picking out the biggest denominator. And we're going to shorthand this one like the other example. We're going to put a question mark there to represent, is 18 the common denominator that we want? Which is a short version of, is 18 divisible by 12 and divisible by 4? Well, it turns out neither of those numbers goes into 18, so no, that doesn't work. And we're going to bump from the 18 to a 36. 2 times 18 is 36. So, does 12 go into 36? Yeah. Does 4 go into 36? Yeah. Our least common denominator for this particular problem, well, that turned out to be fast to find it. That was a 36. Sweet. So I need now to have my fractions adjusted so that they will each turn into something over 36. So my first fraction has an 18, and we just said 18 times 2 will give me a 36. And if I put in a times by 2 on the bottom, then I want to put in a times by 2 on the top. That will get me a fraction 2 over 36. The fraction in the middle has a 12 on the bottom. I need to create a 36. 12 times 3 will get me there. And if I put in a times by 3 on the bottom, I need to put in a times by 3 on the top. So that will give me a fraction of 21 over 36. And then I have my last fraction, which currently has a 4 on the bottom, but I need a 36. So 4 times 9 will get me there. And I have to put a times by 9 on the top also, which will give me 9 over 36. So, now that all of my fractions have that common denominator of 36, I put my numerators together. I keep my denominator the same, and I come up with a 32 over top of a 36. Then I have to remember at the very end of my fraction problems, can I reduce? I always want to make sure before I move on to ask myself that question, can I reduce? Well, 32 on top, 36 on the bottom. I'm looking for something that'll go into both of those. 2 will work. 4 will also work, and it turns out that that's as big as I can go. So I'm going to go ahead and take that fraction and reduce by 4 goes into 32 8 times. 4 goes into 36 9 times. I seem to be getting a fraction answer 8 over 9. Is there anything else that I can do to reduce that? No. So final answer, 8 over 9. An example with subtracting. 18 over 25 minus 4 over 35. Again, got to find a common denominator to start things out. And we are going to be looking for the least common denominator, which means that we're going to start with the 35. Put a question mark there to be representing, is 35 the number we're looking for? More specifically, does 25 go into 35? Sadly, no. So we will move on. 2 times 35 gives us 70. 25 doesn't go into that. 3 times 35 gives us 105. 25 doesn't go into that. 4 times 35 gives us 140. 25 doesn't go into that. And 5 times 35 gives us 175. 25 does go into that. So we have a least common denominator of 175. So we need both of our fractions to have a 175 showing up in the denominator. 25 goes into 175 7 times. So times by 7 on the bottom. And automatically that means times by 7 up on top. This will give me a 126 over 175. My other fraction has a 35 on the bottom. Don't forget that we just went through 35, 70, 105, 140, 175. 35 times 5 gave me that 175. So times by 5 on the bottom and times by 5 on the top. Now that both my fractions have that common denominator, I can put my numerators together. 126 minus 20. I keep the denominator the same, 175. So I get a 106 on the top, I got a 175 on the bottom, and I need to ask myself before I move on, can I reduce? I built the 175, so I know numbers that will work with that. Let's see if any of them work with the 106 on the top. 5 does not go into 106. 35 can be broken apart as a 5 times 7. I know the 5 won't work, but what about the 7? 7 go into 106. Nope. Those are the only possibilities that I have. 7, 5, another 5. That's it. That's all I can try. Nothing else going to work with the 175. And since none of that worked with the 106 on top, we're done. That's the final answer. That is the best we can do. There's no other reducing to worry about. At this point, having discussed the multiplying, the dividing, and now the adding and subtracting, we can put everything together as we had with our integers and come back to the order of operations. So some quick comments about the order of operations. The order of operations is exactly the same as it was when we had discussed it at the end of our integers. Parentheses to represent parentheses, brackets, curly brackets, absolute value bars. E for exponents. M for multiplying, D for dividing, A for adding, S for subtracting, the arrows to remind me to do multiplying and dividing as I read things left to right, to do the adding and subtracting as I read things from left to right. So if the order of operations is the same, basically I just need to remember how to work with fractions to be able to work things out. So I wanted to do the square root example first to make sure that people were kind of putting things together the right way. The square root, we had said, referred to a question, what number squared, or what number raised to the power of 2, would give us 1/4? Well, remember that these powers of 2, special multiplication problems. Multiplying with fractions. So the nicest thing for multiplying with fractions was multiply straight across. Well, then let's break it apart. Up on top, if we multiply straight across, blank times blank is going to give me the 1 up on top. That's like asking myself, what's the square root of 1? And that was 1. Multiplying straight across for the bottom stuff, blank times blank would give me a 4. Well, it's not just any numbers, but specifically it's going to be a square root of 4 that we want for that down there. And the square root of 4 is 2. So we can actually do square roots with fractions by breaking them apart. We do the square root of the top separate from the square root of the bottom, and that would give us the top and the bottom parts of our answer. So we've got a nice thing that came from combining something old about square roots with something newer about multiplying fractions straight across. Then we've got a more traditional example for the order of operations where we have parentheses 2/7 parentheses power of 2 divided by parentheses 2/7 minus 1/21. So based on reading that and considering our order of operations, the first set of parentheses does not have any actual math calculations inside. The second set of parentheses does have subtracting. So that means that we would need to start out with a least common denominator. Actually, I'll tell you what, let's go ahead and rewrite that like so. Start out with a least common denominator. we're going to start with the largest denominator, which is a 21. Will 7 go into 21? Yes. So this is that very lucky situation that I have mentioned would be our best case scenario. The biggest number in our denominators is exactly what we're looking for, and we have just very quickly figured out our LCD. We need to tweak that first fraction though, so that it would have a 21 on the bottom, which means that we would need a times by 3 on the bottom. And what we do on the bottom, we do to the top, so we need a times by 3 up there on the top. That gives us a 6 over 21. The second fraction already had a 21 on the bottom, so we didn't need to touch that one. It's perfectly fine the way that it is. We go ahead and add and subtract fractions by putting the numerators together and keeping the denominator the same. And once we've taken care of that, we ask ourselves if we could reduce. There's nothing that will go into both the top and the bottom of that particular fraction, which means that we can now go ahead and put that into play with our other parts of this problem, parentheses 2 over 7, parentheses power of 2, divided by the fraction that we just came up with is a 5 over 21. Well, let's go ahead and continue working that one out. According to our order of operations, the next part that we have to worry about is the power. The power is outside a set of parentheses, so for us to work out this next step, we are going to be taking whatever is inside those parentheses and multiplying it by itself. So we have 2 over 7 times 2 over 7. And that will end up giving us a 4 over 49. Now we've got a division problem to work out. Our division problem was keep, change, flip. So we would want to keep the first fraction the same, change the division to multiplication, flip the second fraction upside down. Now we've got a multiplication problem, which again we had said was multiply straight across. And my recommendation was to leave things partly broken, partly factored, so that it would be a little bit quicker for us to see whether we could slash anything out to get a reduced answer. Can't work with the 4, can't work with the 5, 21. 3 goes into 21, 7 goes into 21. 3 does not go into 49, but 7 does. So we can do a little bit of reducing here at the very end by 7 goes into 21 3 times. 7 goes into 49 7 times. So that we have 4 times 3 is 12. And down on the bottom, 7 times 5 is 35. So our final answer for that order of operations example, 12 over 35.